This video is based on a new meta-heuristic algorithm named as Honey-Badger algorithm. In this video, we will try to understand how this algorithm is working step by step using different examples. First of all, as you can see here, Honey-Badger algorithm is introduced in 2021. It is a nature-inspired population-based meta-heuristic optimization algorithm that is basically inspired by the intelligent foraging behavior of honey badgers. This algorithm simulates the food search and digging behavior of honey badgers. This algorithm performance is evaluated using 24 different benchmark test functions, and it is also applied to solve 4 complex engineering design problems. And when this algorithm is compared with 10 different meta-heuristic algorithms, it provides excellent results. Now we will try to understand how this algorithm is working step by step. First, we will try to understand about honey badger and its foraging behavior in real life so that we can easily understand honey badger algorithm simulation. Honey badger is a medium-sized carnivore mammal that is the world's most fearless animal, and they are known for their fearless and aggressive attitude. They are highly intelligent and live solitary. Honey badger are known for their love of honey. Honey is the one of honey badger favorite food. They have keen sense of smell and they can locate beehives from distance. Now here you can see the bee attack on the honey badger. Due to their loose and thick skin, they are able to tolerate bee stings, and they also use their powerful claws and teeth to break open the beehives. Here you can see they have powerful claws about 4 centimeters, and honey badgers are found across Asia, Africa in dry, grassy habitats. Even they are also found in semi-deserts. The largest honey badger found in Africa, length is about 55 to 77 centimeters and height is about 23 to 28 centimeters. Female honey badgers are smaller than male honey badger. Honey badger diet include both plants and animals, as they are attracted to honey, but honey is not the only food in their diet. They also eat insects, beetles, termites, larvae, frogs, small birds, snakes, and lizards. Honey badger lifespan in wild is about 7 to 8 years and in captivity 24 years. Now here you can see we have different honey badger predators. Honey badgers often try to avoid troubles and they only attack when they are triggered by their predators. Large carnivores such as lion, hyenas, leopard, wild dog, and for young honey badger, we have small predators like owl, eagle, and snakes. So here you can see we have different large and small predators for honey badger. Now we will try to understand how this algorithm is working step by step. Here you can see we have different steps used in this algorithm. First, we will initialize the algorithm parameters, that is the population size. It means how many search agents we are using in the current population. Next, we have different user-defined parameters for honey badger behavior, and then maximum number of iterations, that is how many times the loop will repeat. In step 2, we will initialize the position for the agents in the search space randomly. Here suppose I is the agent, n is the total number of agents in the current population. So this is the population size. D is here the design variables, or you can say the dimension. So here using this equation we will initialize the position for each agent in the search space randomly. Next, using any objective function, we will evaluate the agent's performance in the search space. So here we will apply any fitness function on the agent's position, and then we will calculate the fitness value for each agent. In step 4, we will save the best agent among all. So here we will compare the agent fitness value and then we will select the one among all. So we will consider the minimum fitness value as the best fitness value. Suppose we have 3 agent, and for 3 agent you can see we have the position and fitness value. Among all, first agent fitness value is better as comparison with second and third agent. So we will consider the first agent as the best agent among all. And in honey badger algorithm, we will consider the best agent among all as the target. In the next step, we will update algorithm parameters. So here we have density factor. Density factor is used to control randomization to make the balance between exploration and exploitation phase. And this parameter decrease with iteration to decrease the randomization with time. And here you can see C, that is any constant, and its value is greater than or equal to 1. So here you can see C, that is any constant, and its value is either greater than or equal to 1, and by default it is used 2. Small t, that is the current iteration, max t, that is the maximum number of iteration. Next we have another parameter, that is the intensity calculation. Here this is the smell intensity of the target. As we know, according to square inverse law, the intensity of light to an observer from source is inversely proportional to square of distance. That is, closer the light source, brighter it is. So this is another Newton law of gravitation. As the distance between two bodies increases, electric force goes down. So in this algorithm, we will calculate the intensity, that is the concentration strength of target, and the distance between target and the honey badger. So here this is the smell intensity of the target, that is equal to R2, that is any random value between 0 and 1. It is normally distributed. S is here the source strength, and we can calculate value for S using this equation. And here di is the distance between the target and the honey badger. X prey is the target position, xi is the honey badger position. Now we will try to update agent's position in the search space. For locating food sources, honey badger either smells, digs, or follow honey guide bird. So here in this algorithm, we can update agent's position in the search space using digging phase and honey phase. Digging phase is used for exploration and honey phase is used for exploitation. Now we are going to update the agent's position in the search space. So here we will check the value R, that is any random value within 0 and 1. If this value is less than 0.5 or not. If this condition is true, then we will perform the digging phase, else we will perform the honey phase. So first we have digging phase. In digging phase, honey badger uses its smelling ability to locate the target. In the digging phase, honey badger uses a smelling ability to locate the target, and when the target location is found, honey badger move around the target to select the right place to dig and hunt the target. In this phase, honey badger behavior is based on cardioid motion. Cardioid, that is heart-shaped plane figure. And here you can see this is the target location, and black line you can see here. This line indicates the smell intensity. So first we will calculate the target smell intensity, and then accordingly we will update the honey badger position around the target. Using this mathematical model, we can perform this simulation. So using this mathematical model, we can update agent position in the digging phase. Here you can see this is the target position. Next, here you can see R3, R5, R4, that is a random value normally distributed between 0 and 1. Di, that is the distance between the target and honey badger. Here this is the cardioid motion. F is here any disturbance, that is calculated using this equation. Here this is the search direction, that is changed based on F value. Here, during digging, honey badger may receive disturbance, and that is simulated using this equation. R6 is here any random value between 0 and 1, and we will check if this condition is true, then value for f is 1, else -1. After digging phase, now we will perform the honey phase. In this phase, honey badger will follow honey guide bird to reach the beehives. In this phase, honey badger and honey guide bird cooperative behavior is simulated. Honey guide birds are known for their unique behavior of leading animals and human to beehives. By doing this, bird is able to get a small portion of honey that is left behind. And here you can see this is the mathematical equation that is used to perform the honey phase, that is the exploitation phase. Here you can see this is the target position, f, that is the disturbance, and here this is the distance between the target and the honey badger. R7 is here any random value that is normally distributed between 0 and 1. Next step. So here you can see now honey badger position is updated. In the next step, we will evaluate the new position using any objective function. Now, in next step, we will evaluate new position using objective function. So here you can see we have the older position and the fitness value. Now we will apply the fitness function on the new position, and then we will calculate the fitness values. After that, we will compare the agent's fitness value, whether the new fitness value is better than older one or not. So now we will compare the new fitness values with the older fitness values. Here we will check whether the new fitness value is better than older one or not. If the new fitness value is better than old fitness value, then we will consider the new position and the new fitness value for that agent. Else we will consider the older position and the fitness value. So for all agents, we will compare the fitness values and then update the solutions. And after that, in step 8, we will save the best agent among all. Again, we will consider the minimum value among all as the best solution. After that, we will check the stopping condition, whether the current iteration is less than or equal to maximum iteration or not. If stopping condition is met, then stop and display the best solution that is found. Else we will repeat the loop. We will update the parameters, position, and then again evaluate their position using objective function, compare fitness value, save the best agent until the stopping condition is met. So here you can see this is the pseudocode for this algorithm. First we will initialize the parameters, and then initialize agent position randomly in the search space, calculate the fitness value using objective function, save the best agent, and then we will start the algorithm main loop, update main parameters, and then for all agents we will update their position, calculate new position and the fitness value for each agent, and then compare their fitness values and save the best agent. Repeat the loop until the stopping condition is met, and when the stopping condition is met, stop and return the best solution that is found. So that's all about this video. If you have any question, you can comment below, and thanks for watching this video.